Good morning, everyone. Today we are going to discuss about sea level rise or sea level change. Okay. Okay. Climate benchmark provides key evidence regarding climate change and helps estimates rates to past geological uplifts. Coastal features informs the stability of coastal locations for industrial development and influences erosional and depositional processes. Global food security determines the availability of fertile coastal agricultural land. Future submergence could be a disaster for human civilization. Strategic planning enables low-lying counties to build defense-like coastal dikes and helps identify suitable locations for tidal power generation plans. Okay, these are some importance of understanding the sea level rise, concept of sea level rise or sea level change. Okay, these are some basic importance of understanding sea level rise. Okay, it's all relative. Sea level change is the fluctuation in the mean sea level. Okay, sea level change is the fluctuation of mean sea level, means upward and downward. It is a relative change, the result of movement between the sea surface and the land. Okay, sea rises, land stable. Okay, land is stable but sea is rising. It's called sea level rise. Sea is stable, land sinks. Sea is stable, and on the other hand, sea is stable and land sinks. It's also called sea level rise. Both can rise or fall. Both can rise or fall. These are three different phenomena occurring in sea level rise. Okay, that water and land main dominating factors of sea level rise. First of all, water and land. Geostatic sense, the volume of water in the ocean sense, it is a global effect like adding water to a bathtub. Tectonic and isostatic sense, the level of the land itself moves up or down. This is often a local or regional effect. Now, when the water itself rises or falls, there are two consequences: glacial change and thermal expansion. Okay, during ice ages, water is locked in ice sheets like this, causing sea levels to fall. During warmer periods, melting ice sheets and glaciers add vast amounts of water, causing levels to rise. Okay, whenever the ice begins to melt, the sea gets more water and it gets sea level rise. On the other hand, as global temperatures rise due to anthropogenic activities, the ocean water warms and expands, increasing its total volume. Key statistics: if all the ice of Antarctic and Greenland melted, sea level would rise by 65 to 80 meters. After accounting for isostatic sinking of the ocean floor from the added weight, the net rise is estimated to be 40 to 50 meters. Okay, now the changes in the level of the land driven by tectonic forces, that is plate tectonic, are the second critical pieces of sea level puzzle. That means sea level change. Okay, another causes of sea level rise is tectonic forces. The ground itself can rise, sink and tilt or buckle over geological time, creating an apparent change in the sea level along a coastline. Okay. First of all, land in motion, the rebound effect, isostatic change. Isostatic change occurs from the addition or removal of immense weight on the Earth's crust. Land masses sink under the load and slow rise again when it's removed, like this. Okay, this is the addition or removal of weight, removal of weight, and slowly rise again when it's removed. After remove, the landmass rises. The landmass of Scandinavia is still rising today, rebounding from the weight of the ice age glaciers that have since melted. Land in motion 2, the grand tilt, epirogenic movement. Epirogenic movement is the broad scale tilting of entire continents. This process can cause one edge of a continent to rise relative to sea level, while the opposite edge subsides, causing an apparent local sea level rise at sea level rise there. Okay, apparent sea level fall, apparent sea level rise. This is a continent, and this is the grand drift. And the big squeeze, that is orogenic movement. Orogenic movement is related to the folding, flexing and thickening of the Earth's crust when tectonic plates collide to form mountains. Smaller continental area to larger ocean basin to lower global sea level. This process reduces the total surface area of the continents. As a result, the volume of the ocean basin increases, causing a global fall in sea level. Beyond the shore, when the basin itself changes shape, the volume of the ocean basins was a major factor in sea level changes during the Mesozoic and early Cenozoic eras. Two tectonic processes alter the container that holds the world's ocean. mid-oceanic ridges, and sediment accumulation. When the seafloor spreads faster, the mid-oceanic ridge systems increase in volume. This warmer, large ridge displaces water, displacing global sea level rise. Slow spreading when fast spreading sea level rise. When mid-oceanic ridge moving faster from each other, then there is a expansion happening in the sea level. Sediment augmentation. Sediments from the denudation of continents are deposits on the ocean floor. Over time, this accumulation reduces the volume of the ocean basin, causing a rise in sea level. Okay, short-term changes. Beyond the slow march of geology, sea level experiences short-term fluctuations also, typically 5-6 cm annually, but reaching 20-30 cm or more in many coastal areas. These are caused by a complex interaction of factors like water density, ocean currents, atmospheric pressure, and wind and monsoons. Water density. Changes in temperature and salinity after water density. Low temperature and high salinity lead to denser water and lower sea level. Ocean currents. Fast flowing currents, especially on curved paths, cause a rise in sea level on their outer fringe. Atmospheric pressure. Low atmospheric pressure results in a high local sea level as water is sucked in by the upward moving air mass. Wind and monsoons. Also, winds can pile up water along coast in South and East Asia. Sea level rises during the monsoon months due to landward air movement. Okay, these are some caused by intention of the factors. Okay, short-term changes. Cause of short-term changes in the sea level rise. Now, what happens when the sea retreats? A fall in sea level reshapes coastal and riverine landscapes in distinct ways. Extended shorelines. The coastline moves farther out to sea, exposing new land. River rejuvenation. Rivers cut deeper into their valleys as they flow down to a new lower base level. Death of coral reef. Shallow water reefs can become exposed to the air and die. Okay, the forces of sea level change a dynamic balance. Atmospheric pressure, water density, ocean currents, wind, monsoon. Eostatic, ice formation, melting ice and thermal expansion. Tectonic and isostatic, land uplift, isostatic rebound or tilt, land subsidence from weight or tilt. Basin shape, orogenesis, mountain building, and basin shape, fast spreading ridges, sediment accumulation. Okay, while many powerful forces changing our coastlines are geological and operate over millennia, human activity is now a major driver. Global warming in the last century has resulted in the thermal expansion of ocean water and accelerated ice melt. Understanding these interconnected systems is the critical first step toward adaptation and mitigation. Shifting source. Okay, that's all for today. If you have any doubt and query, just let me know in the comment section. Thanks for watching. Thank you.